So this is a question from 2021. It's our O-level A-Maths paper 1 question, question 10. We are asked to prove the identity that sine theta over 1 minus cosine theta minus 1 over sine theta equals to cotangent theta. Okay, so how do we go about doing this? Okay, so usually when you see two fractions and their denominators are different, you will try to make the denominators the same. And usually when you're talking about proving of identities, we will start with the more complicated side. So in this case, it's the left hand side. So I'm going to take sine theta here and I'm going to square it. Okay, so that will allow me to actually make the denominator become 1 minus cosine theta multiplied with sine theta. Because I want to do the same to the other fraction. Okay, so you have 1 minus cosine theta over 1 minus cosine theta multiplied with sine theta. Denominators are the same, so now I can combine them. Sine square theta minus 1 plus cosine theta, and the whole thing will be over 1 minus cosine theta sine theta. Now, sine square theta, we all know, is the same as 1 minus cosine square theta. So, we're going to change the sine square theta to 1 minus cosine square theta minus 1 plus cosine theta. And then this will be our 1 minus cosine theta sine theta. Okay, so the denominator remains the same. Now, simplifying the top, you end up with cosine theta minus cosine square theta. You can pull out the cosine theta, so the 1 and the 1 will cancel out. So cosine theta minus cosine square theta, maybe I'll write that down first, over 1 minus cosine theta sine theta. Okay, so this is where I'll factorize the top, and then I'll pull out my cosine theta, and this will give me 1 minus cosine theta. Okay, so just pulling out the cosine theta leaves you with a bracket that says 1 minus cosine theta, which you can now cancel away because there's also 1 minus cosine theta in the denominator. So cancelling out these two, you end up with cosine theta over sine theta, and that will give you your cotangent theta, which is your right hand side.